Okay, yeah, thinking about generating these text files, and so we're trying to achieve this, and what we're looking at doing is we're going to build this stadium, and we're going to deliver this skin system without any paper drawings. And so the other key component there to allow this to happen, beyond kind of establishing the team mentality to set it up this way, was we needed to talk with the California Board of Architects and establish a procedure that they would approve to allow us to actually submit for permitting with digital files rather than drawings. And so that was something that we did kind of in parallel with
Hmm.
this, is that we created a procedure and a prototype, a very crude kind of interface that would allow us to stamp and seal anything from a Rhino model to a CSV file. In a way that could be delivered and verifiable as the document that the architect had stamped and sealed. So we do have the provisions in place to allow us to submit for permitting with no drawings.
Huh. How did you digitally stamp these models?
So essentially, what we did was we kind of looked at what's been going on online for many years, and we're
Yeah.
using a unique hash code
Okay.
that's associated with each of these files, and so that's something
Hmm.
that you can use. If you're going to download something and you want to verify that it's authentic, you can
Hmm.
compare that hash against what it should be,
Hmm.
and if it gives you the green light, essentially what we've created will show the architect's stamp and seal.
Hmm.
And if that hash code is not correct, meaning that it could be something as simple as someone opened the file and closed it again or moved a comma, it's going to give you the red lights, and you won't see a stamp and seal, so you know that you're dealing with a file that is either out of date or corrupted or the wrong file. So.
Interesting. So sort of implementing some of the, like, let's say DocuSign kind of technology into your models, basically.
Yeah, yeah. Essentially, just finding a way to make that appropriate for the
Hmm.
architecture profession, I guess.
Okay. So you've taken the project to this level. And many aspects of it, as we just discussed, are really at the leading edge of what people are doing in our profession. Tell us a little bit more about sort of the next things you guys are thinking about.
Yeah, and this is always something that's fun to talk about. So, we mentioned we have some people of some varying backgrounds in the studio, and James Wharton is a PhD candidate in mechanical engineering, and he has kind of brought to the team some peripheral studies into additive manufacturing. So if we go to the next slide here, if you can recall, we've kind of talked about the perforations and the triangular panel aggregation, and we have these 70,000 unique panels. Well, at the vertices between 6 of each of these triangles, if we go to the next page, we have what's called a spanner. And this is something that would be similar to like a spider connection that you might see on like a Pilkington planar system glass or something like that, right? So it's kind of clamping the points of all these triangles together at a vertices. And so if we choose a spanner that can kind of be globally optimized, it's going to be an off-the-shelf product, and it could work at the interface of these panels everywhere over the whole skin system. However, it won't work optimally at all solutions. It has to have enough variability and tolerance built in to accept the different angles that these are coming together at different places on that curving surface. So we could think about, well, if we locally optimize the spanner, we could kind of design something that works specifically for one specific vertice. However, as you can imagine, if we were going to try to manufacture those by traditional means, that would be a lot of spanners that we would have to create. So if we go to the next slide, we can kind of see what we're talking about here. So we've indicated with the red dots, there would be a spanner in each of these locations. And so imagining if we could take advantage of additive manufacturing and look at some things like 3D printing of metal alloys. The next slide will show what's called electron beam melting. And that's essentially using a laser affixed to the end of a robotic arm to melt powdered alloy into place in three-dimensional space so that we can kind of build up layers and create a component by an additive manufacturing process rather than kind of milling it out of a block. And so, what this would allow us to do is to create these custom pieces in a way that that not only would be quicker than creating the traditional process to put in place to cut them out of a die or to cast them or so forth, but we can also use a lot less material to do so. And so the next image, a couple of images show just essentially some studies that that James has been doing that we've used to kind of fuel this study into how can we start to optimize our structural components in a way that we can kind of trace load paths and kind of carve away all the unnecessary material so that we're really creating optimized structural pieces. And this is really something that that we're pursuing, and we're getting some prototypes of these optimized spanners printed here very soon, in the anticipation that the next NFL stadium we build might have some 3D printed metal structural components on it.
Awesome, and really incredible stuff. Is there anything else that you guys are doing over there? Jesus.
It's fun stuff. I have the honor to work with some smart individuals, and we have some great clients and some amazing projects that we can work on. So
awesome. If I'm not mistaken, I think you told me that everyone who listened into this, they get free tickets to the opening day at the Ram Stadium. Isn't that right? Something like that.
I think if you told them that, I'll be okay.
There you go. Good. All right, guys. We'll take some questions here. Let's see. I think the question I have here from Dan Anthony is probably a good one here that many architects are probably thinking, and it's more of a artistic sort of question, but I'll ask it anyways. He's curious about how you might better, us as architects, be better about image mapping to actually meet performance characteristics. And tuning an image to give a better shade, for example, at different times of the day, maybe versus considering the images, or the perforations from primarily an aesthetic perspective. Again, that's kind of a value thing. So I guess you could kind of, maybe you value it one way or the other. But I'm just curious if you have any thoughts about how you guys might consider doing something like that, where you can tune the perforations to something other than just aesthetics.
Yeah, we do, and that's that's something that I value personally very much. And so we have we've actually done a lot of investigation and study into this, and we're doing work on other projects, not this one specifically, but we're doing exactly that. We're kind of taking this artistic brushstroke, or this this water droplet that's this idea, and that image can then be processed, and we're using things like Galapagos for evolutionary solving, within the grasshopper environment, and then even taking that further to use octopus, which allows us to do evolutionary multi-criteria optimization. So we can start to kind of take sometimes these diametrically opposed criteria and solve for multiple criteria at once. And so by using an evolutionary solver, we can kind of tune into the specific location and start to study things like daylight and heat gain, and we can manipulate these images or even create new images that really respond kind of sympathetically with the environment.
Mm-hmm. Awesome. All right. Well, good question, Dan. Thanks for asking that. All right. Well, I'm going to go ahead and close it up there. So thank you, Heath, for sharing your amazing project with us, and thanks to all of you who've tuned in and who submitted their questions today. If you'd like to attend our next Super Simple broadcast on December 7th, where we'll feature Marc Fournier from The Very Many, he's going to talk about two similarly incredible projects. You can register for that episode at blackspectacles.com/podcast. To learn more about our software tutorial curriculum, you can go to blackspectacles.com, where you can try out some of the free course videos. So please let us know what you think and share any suggestions you may have. I promise we'll read every word that you write and use them to tune our next episodes. So thanks for watching.
Thanks, Mark. Thank you, everyone.